So here's a question that's asking you to solve for a very specific answer. An IV pump is set to deliver 13 milliliters an hour. The IV solution is labeled 1 gram and 250 milliliters. And the wanted, they're asking you how many milligrams an hour of the medication is the patient receiving. So right away, you should say my wanted is milligrams an hour. And the IV pump is set to deliver 13 milliliters an hour. That's volume over time. So that's where I'm starting, 13 milliliters an hour. So the doctor's saying, I want this medicine in this solution to run at 13 milliliters an hour. But you need to figure out how many milligrams an hour are they actually receiving of that medicine. So I have my starting point, volume over time, that's 13 milliliters an hour. That's what the infusion rate is. They're getting this through an IV pump. How do we know that? Because it's saying milliliters an hour. But they're asking you for something specific. How many milligrams an hour of the medication? So we still follow the same process. We get rid of our unwanted units and try to solve for the wanted. So I need milligrams in my numerator, an hour in my denominator. Well, when I start with volume over time, if you look, I already have my denominator, hours. So how do I get rid of milliliters? Well, I look towards my problem. I've already used my 13 milliliters an hour. I already know what I'm solving for. So what can I use in my problem to get me to milligrams and get rid of milliliters? Well, I can use what's in my problem. If I say 1 gram is 250 milliliters, that gets rid of my milliliters. Now I have to get rid of grams and find milligrams. So we go into our arsenal of conversions, and I know that 1 gram is 1,000 milligrams. That gets rid of my grams, and it gives me milligrams in my numerator. So when I look at my problem, everything that is unwanted is gone, and I'm left with exactly what I need. So now you know it's just math. So 13 times 1 times 1,000 is 13,000. And 250 times 1 is 250. When I divide 250 into 13,000, it gives me 52. So the answer on my answer sheet will be 52 milligrams an hour. So what does this mean? It means that the order to deliver 13 milliliters an hour is also giving the patient a strength and a dose of 52 milligrams an hour. So pause it here if you want to give it a shot. All right. So here's a problem. An IV pump is set to deliver 20 milliliters an hour. The solution is labeled 2 grams and 150. How many milligrams an hour of the medication is the patient receiving? So my wanted is milligrams an hour. My order is to infuse. My given, volume over time, 20 milliliters an hour. I have my hour in my denominator. I need to get rid of milliliters. So I look to my problem. I've already used this. I know I'm solving for this. So I'm going to use what's in my problem. 2 grams and 150 ml. That gets rid of my milliliters. How do I get rid of grams and go to milligrams? My conversions. 1 gram is 1,000 milligrams. That gets rid of my grams. I have hour and I have milligram. I am all set to solve. So 20 times 2 times 1,000 is 40,000. And 150 times 1 is 150. When I divide 150 into 40,000, it gives me 266.66. I use my rounding rule, 6 is greater than 5. So this patient is receiving 267 milligrams an hour. And that's how you write it on your answer line. So here's a different way. Same kind of problem, just asking for a different answer that you were completely capable of solving. So IV medication, there's 250 milligrams in 250 milliliters of D5W. It's already running at 50 milliliters an hour via a pump. How many micrograms a minute is the patient receiving? So my wanted, it's telling you how many micrograms a minute. And where do I start? My volume over time. That's what the doctor ordered. Run it at 50 milliliters an hour. So when I look at my problem, I'm somebody that likes to cross off what I used. So how do I get hour to minute? You know, 1 hour, 60 minutes. When I do that, I get rid of hour and I get minute in my denominator. That's exactly what I need there. But now how do I get to micrograms and get rid of milliliters? Well, I use what's in my problem. There's 250 milligrams in 250 milliliters. That gets rid of my milliliters. Now I have to get rid of my milligrams. How do I get rid of milligrams? Let me cross that off and get to micrograms. I go to my conversion vault. 1 milligram is equal to 1,000 micrograms. That gets rid of milligrams, and guess what? I have micrograms in my numerator. So now I'm ready to solve. So 50 times 250 times 1,000 is some crazy number like 12,500,000. And 250 times 60 is 15,000. Certainly, if you are someone that's savvy with your zeros, go for it, but just be careful. And when I divide 15,000 into 12,500,000, it gives me 833.33. I round that up following my rounding rules. 3 is less than 5, so I don't need to round up. So the patient is getting 833 micrograms per minute. And that's what I write on my answer line. Here's a 3-factor IV problem. And how do I know it's 3-factor? Because it's saying the IV is to be administered at 15 micrograms per kilogram per minute. That's 3 elements, 1, 2, and 3. So if you remember back to your 3-factor problems, that's your starting point, because that's what the doctor ordered. So we set it up, 15 micrograms in the numerator and kilogram per minute in your denominator. It's saying that the IV solution is labeled 250 and 250 with a drop factor of 20. The patient weighs 110 pounds. Calculate the infusion rate for the IV pump. So what's the rule? When it says IV pump, we do not need the drop factor. And it's asking for the infusion rate for the IV pump. So my wanted is always milliliters an hour. All right. IV pump means milliliters an hour. I do not use the drop factor. So how do I get milliliters an hour with all of these things that I need to get rid of? So these are huge problems to solve. But if you remember, if you just focus on getting rid of the unwanted and solving for the wanted, you're going to get there. You have to get milliliters in your numerator and hour in your denominator. So it doesn't matter how you start it, but let's say you want to start with your minutes to hours. Well, we know that there's 60 minutes in 1 hour. That gets rid of my minutes, and I have my first part, hour. So how do I get rid of kilogram? I use what's in my problem. So to get rid of kilogram, and the patient's weight is provided in pounds, I know I need a conversion. 1 kilogram is 2.2 pounds. That gets rid of my kilogram. Now, how do I get rid of this pound? I use the patient's weight, 110 pounds. Cross off what I use. This gets rid of my pounds. Put that over 1. So now all I have to do is focus on getting rid of micrograms, and I have to find a way to get to milliliters. The only thing left in my problem that I haven't used is this 250 and 250. So this is micrograms, but this is in milligrams. So I know I need a conversion. 1 milligram is 1,000 micrograms. That gets rid of micrograms. Now I have to get rid of milligrams and somehow get to milliliters. Look at my problem. There's 250 milligrams in 250 milliliters. That gets rid of my milligrams. And look at that. It gives me milliliters in my numerator. Now you know, now it's just math. So like I said, if you want to do crossing off your zeros, go for it, but just be careful. I'm going to do the long way. 15 times 60 times 110 times 250 is crazy, but it's like 24,750,000. And 1,000 times 2.2 times 250 is 550,000. When I divide that into my 240, it will give me a beautiful 45, and that's milliliters an hour. And that's what I put on my answer line. Here's another one. Same thing, 3-factor. Pause it here if you want to give it a shot. So an IV medication is to be administered at 25 micrograms per kilogram per minute. It's labeled 300 milligrams and 500. The patient weighs 60 pounds. Drop factor 20. Calculate the infusion rate for the IV pump. So there's my word, pump. So that means what? I don't use the drop factor. And they want an infusion rate. With an IV pump, an infusion rate, a flow rate is always milliliters an hour. So I've used my pump, I figured all that out. I know what I'm solving for. So my starting point is the 3-factor order. 25 micrograms per kilogram per minute. Again, start anywhere you want. Let's get rid of the micrograms. Well, my problem has, I've already used this one. My problem has a milligram in it, so I know I need a conversion. So 1 milligram is 1,000 micrograms. That gets rid of my micrograms. Now I have to get rid of milligrams and somehow get milliliters in my numerator. Well, I go to my problem. 300 milligrams in 500 milliliters. That gets rid of my milligrams and it gives me my milliliters. I've used that. Beautiful. So how do I get rid of kilograms? I have a weight that's in pounds. So 1 kilogram is 2.2 pounds. Gets rid of my kilograms. Now how do I get rid of pounds? I use the patient's weight. 60 pounds. Put that over 1, that gets rid of my pounds. But now I have to get rid of minute. 60 minute in 1 hour. And that gets rid of my minutes. I look over my problem. I've gotten rid of everything and I have only my wanted. So now it's just math. So again, I do the long gross way. When you multiply across the top, it gives you 45 million. Then multiply across the bottom, it gives you 660,000. When I divide that into each other, I get 68.1 and I round it. And because 1 is less than 5, I don't round up. And that's 68 milliliters an hour. And that's what you're going to set your IV pump at to give this patient with this weight, this strength every minute. So here's a 3-factor IV problem, but it's asking you to solve for a 3-factor. So I wanted to review this with you. So when we look at this problem, it says an IV medication of 600 milligrams in 500 mLs of D5W is infusing at 80 milliliters an hour via pump. How many micrograms per kilogram per minute of medication is a 90-pound patient receiving? So it's asking you to solve for micrograms per kilogram per minute. So this is the reverse of the 3-factor that we started with in the last problem. It's asking you to solve for the 3-factor. But if you remember what we always say about the IV fluids, it's already running at 80 milliliters an hour. That's what the doctor said to run it at. So we start with the volume over the time. 80 milliliters an hour. So I need to find micrograms in my numerator and kilogram a minute in my denominator. So if you thought the other ones were crazy, this is just as crazy. But these are definitely solvable problems as long as you focus on getting rid of the unwanted and getting to the wanted. So let's start this problem. So I know I'm solving for micrograms per kilogram per minute. I have to get rid of milliliters and hours. So let's start simple. Let's get rid of hours. Change that to minute because I need minute in my denominator. So 1 hour is 60 minutes. That gets rid of my hours, and I have one part of my problem. How do I get milliliters to micrograms? Well, I've already used my 80 milliliters an hour, but I have this conversion in my problem. But it's in milligrams, and I need micrograms. Or I can get rid of my milliliters first. So we can do that first. We can say 600 milligrams is in 500 milliliters. That gets rid of my milliliters. How do I get milligrams to micrograms? You know it. Conversion, 1 milligram is 1,000 micrograms. That gets rid of my milligrams. I have my numerator. So how do I get kilograms? And this is the part that people struggle with. I have a weight that's pounds, but I need kilograms in my denominator. So I need to start with the kilograms in my denominator. 1 kilogram is 2.2 pounds. So I have kilogram, but now I have to get rid of pounds. How do I get rid of pounds? I use what's in my problem. It doesn't matter where you put it as long as you can cross off the pounds. So in this case, I'm putting 90 pounds here. That gets rid of my pounds. And now I'm ready to solve. I've gotten rid of everything except for what I needed. I have kilogram, I have minutes on the bottom, in my denominator, and I have micrograms in my numerator. So now we just solve for math. Now this is a pretty huge problem. So I'm going to cross off zeros. So I'm going to show you how I do it. I cross off 1, 2, 3. So I can do it here. 1, 2, 3. 1, 1. So now I'm going to do math. 8 times 600 times 1 times 2.2 is 10,560. Now you can do your math any way you want. 6 times 5 times 9 is 270. And when I divide 270 into 10,560, it gives me 39.1. And when I round that, I round down. I don't have to round up, so I'm going to make it 39 micrograms per kilogram per minute. And that's my answer. All right, here's another problem. An IV medicine of 120 milligrams, 120 milligrams at 100 milliliters is already infusing via 5 milliliters an hour via pump. How many micrograms per kilogram per minute will a 100-pound patient receive? Or are they receiving? So we're solving micrograms per kilogram per minute. All right, it's telling us what we're solving for. We start with the volume over time. That's 5 milliliters an hour. That's how much the doctor prescribed to give. So again, doesn't matter where you start. We can start by getting rid of milliliters. I can use what's in my problem, 120 milligrams and 100 milliliters. That gets rid of my milliliters. I've used this. Now I have to get rid of milligrams and somehow get to micrograms, and I convert 1 milligram is 1,000 micrograms. That gets rid of my milligrams, and I have my numerator, micrograms. I need minute, and I need kilogram, and I have hour. Well, I know I need kilogram down here, so 1 kilogram is 2.2 pounds. And I have to get rid of pounds because I need this kilogram. So I use my problem, 100 pounds. And I have to put it down here in the denominator position to cross it off. So I get rid of my pounds. So now I have to get rid of only the hour, and I have to make it minutes. So 1 hour is 60 minutes. That gets rid of my hours. I look over my problem. I have my micrograms in my numerator, kilograms and minutes in my denominator. Everything else is crossed off. So now I'm ready to solve. So you can do the long gross math. That's fine. And when you do it, 5 times 120 times 1,000 times 1 times 2.2 gives you like 1,320,000. And 100 times 60 gives me 600,000. When I divide that, I get 2.2 micrograms per kilogram per minute, provided my math is correct. So your answer on your answer line is 2.2 micrograms per kilogram per minute. So remember, setting up your problem, start with that volume over time, know what your wanted is. I told you how many micrograms per kilogram per minute. And then you set it up so you have what you need in your numerator and what you need in your denominator. So here's another one. Pause it now if you want to give it a shot. So let's read it. There's 80 milligrams and 500 milliliters normal saline. It's going to go at 50 milliliters an hour via a pump. How many micrograms a minute is a 90-pound patient receiving? So if this said drop factor 10, you have to know what? You don't use it. Why? Because the problem said pump. No matter what the problem is, if it has a drop factor and the word pump in it, you cross off the drop factor. You do not use it. All right, so we are solving for micrograms per kilogram per minute. I start with my order, my volume over time, 50 milliliters in an hour. And now I just start setting up my problem. So I'm going to cross off as I use it. I've already used this. I know I'm using a pump. So 80 milligrams in 500 milliliters. That gets rid of my milliliters. I have to get rid of milligrams and get to micrograms. 1 milligram is 1,000 micrograms. Looking good. Get rid of my milligrams. Now I have micrograms right where I need it. I know that 1 hour is 60 minutes. Gets rid of my hour. I have my minutes. Now I got to get kilograms. So kilogram, 1 kilogram is 2.2 pounds. And the patient is 90 pounds. That gets rid of my pounds, leave me with kilograms, and now I'm ready to solve. So when I do this math, it's also another crazy number, but it's something like 8,800,000. And the bottom is 2,700,000. When I divide into each other, it'll give me 3.3 micrograms per kilogram per minute. And that's what you're going to write on your answer line. All right, let's talk time. Let's look at this. This is asking us to solve for time in a very specific time. So they're saying that an IV was ordered 1,000 milliliters of D5W, but it's already running at 70 drops a minute. So I want you to envision this. At 12 o'clock, Professor K walks into the patient's room and she assesses that IV bag and that IV site. And when she looks at the bag, there's only 400 milliliters remaining in that bag. It may have started with 1,000, but when she walks in, Professor K walks in at noon, there's only 400. So I don't care that they're started with 1,000. I'm worried about when I'm there assessing the patient, because if there's only 400 milliliters when I walk in, I need to know when that bag is going to be empty. So Professor K walks in and there's 400 milliliters. So that's my starting point. And this is asking us, what time will this IV finish? Drop factor 20. It's going at 70 drops a minute. All right, I've already used my 400. I walked in, there was only 400 milliliters in that bag. That's my starting point. But I'm solving for time, and time is hour. So I need hour. Okay, so I started with 400 milliliters. How do I get to hour? Well, I look at my problem. What in my problem has milliliters in it? Well, you remember, drop factor 20 means there's 20 drops to make a milliliter. So I'm using that. So 20 drops per ml, and that gets rid of my milliliters. I can cross off what I used. So now how do I get rid of drops? I go to my problem. There are 70 drops running every minute. That gets rid of my drops. And now I have minute. So how do I get minute to hour? The same way we have been. There's 60 minutes, and I have to put this down here in the denominator in 1 hour. Gets rid of my minutes, and I'm left with hour, and that's exactly what I want. So now I solve, and I'm going to get some numbers, but this is not what the question's asking. So this is where you have to pay attention. When I multiply 400 times 20 times 1, it gives me 8,000. And 70 times 60 is 4,200. When I divide 4,200 and 8,000, it gives me 1.90476619. Well, that's not any time I'm familiar with, but what it does represent, anything before the 0 is hours. So that represents 1 hour. But what does this 0.904619 represent? Well, this represents minutes, but not any minutes that we are familiar with. So how do I convert this to minutes? Well, basically what you do is you multiply 0.904619, you multiply that by 60. And when you do that, it gives you 54.28. We follow our rounding rules, and this is less than 5, so we don't round up. This represents 54. So what does that mean? It's 1 hour and 54 minutes. So what do I do with that? Well, it's asking me what time the IV will finish. This is how long it's going to run to get rid of 400 milliliters, but they want the exact time. Professor K needs to know when to go back in that room with a brand new bag of fluid. So Professor K walked in at 12 o'clock. And if it's only going to take an hour and 54 minutes, I'm going to add that to 12. And when I add that to 12, Professor K is going to walk back in that room at 13:54 with a brand new bag of IV fluids. And 13:54 represents our military time. So the IV will finish at 13:54. And if you remember, 13:54 is equal to 1:54. But you're only going to write military time. So the answer to what time will this IV finish is 13:54. And that's all you write in your answer line. So let's do another. Pause it now if you want to try it on your own. So this is saying that doctor ordered 1,000 milliliters of normal saline, and it's already running at 25 drops a minute. At 9 a.m., Professor K walked in the room, and it only had 250 milliliters remaining in the bag. LIB is left in bag. That's what's left in the bag, 250 milliliters. What time will this IV finish? Drop factor 10. Well, drop factor 10 means 10 drops per milliliter, right? So Professor K walked in the room at 9, and there was 250 milliliters in that bag. And I'm solving for time, so I need hour. So I've already used my 250. So how do I get rid of milliliters? I use my drop factor, 10 drops per milliliter. That gets rid of my milliliters. How do I get rid of drops? I use what's in my problem. 25 drops per minute gets rid of my drops. I've already used that. And how do I get minutes to hours? 1 hour is 60 minutes. That gets rid of my minutes. So I have hours and nothing else. Everything else is crossed off. So now it's just math. So 250 times 10 is 2,500, sorry. And 25 times 60 is 1,500. When I divide 1,500 into 25, it'll give me 1.666666. I usually go like the 6 numbers. All right. So the number before the decimal represents hours. That's 1 hour. So now, how do I get minutes? I take 0.66666 and multiply that by 60. And when I do that, it'll give me 39.99. I round that to 40 minutes. So it'll take 1 hour and 40 minutes for this IV of 250 milliliters to infuse, to finish. But that's not what it's asking me. It's asking me what time it will finish. So I walked in at 0900, and if it's going to take an hour and 40 minutes, I need to walk back in at 1040 with a brand new IV bag. So the answer to this question, what time will this IV finish? The time is 1040, and that's all I write on my answer line. Pause it here if you want to try. So there's an IV that's running at 80 drops a minute. When they hung it, it had 1,000 milliliters. But when I walked in at 1300, there was only 350 milliliters left in the bag. So Professor K walks in the room to assess her patient, and there's only 350 milliliters in the bag. That's where I'm starting. So I've used my 350. I don't care about the 1,000, that's the original. So now I'm solving for what? What time will this finish? Hours. So use what's in my problem. It's going. It's got a drop factor of 20. That means 20 drops per milliliter. That gets rid of my milliliters. How do I get rid of my drops? I use 80 drops a minute. 80 drops per minute. Gets rid of my drops. How do I get minutes to hours? 1 hour is 60 minutes. That gets rid of my minutes. I look over my problem. I have only what I need. So now I have to solve, multiplying the top. 350 times 20 is 7,000. And 80 times 60 is 4,800. When I divide 4,800 and 7,000, it gives me 1.45833333. Remember, anything before the decimal represents hours, so that's 1 hour. And 0.45833 times 60 will give me 27.499, 27.4999. But either way, I'm rounding that to 27 because 4 is less than 5, so I don't round up. So that's 1 hour, 27 minutes. So what time am I going back in with that IV bag? Well, I walked in at 1300. It's going to take 1 hour and 27 minutes to run. So I'm walking back in with a brand new bag at 1427. And that's what I'm writing on my answer line, 1427.